All right, I hope now you have a little bit better understanding what p-value is. Let's talk more about the hypothesis testing. Well, first of all, let me remind you, our assumption of the population which we use to make a test consists of two things. It's the expected value and the direction. And this assumption we call a null hypothesis, right? But what if you have an evidence against null hypothesis? What if the chance, the p-value that you computed for your sample clearly indicates that it's almost impossible to get this particular sample or more extreme from the null hypothesis, from the population you have null hypothesis about? What to do in this case? Well, in this case, you need to have another hypothesis, right, which will be alternative to your default hypothesis. And that's exactly what we have, alternative hypothesis. For example, for this assumption, for this null hypothesis, alternative hypothesis will be below 10. And you take alternative hypothesis only if you have a very strong evidence against the null hypothesis. So that's what p-value we will use p-value for. We will assume how big p-value is. P-value enough? Is this chance big enough to support null hypothesis? Or it's too small for the null hypothesis to be true, and therefore we should consider alternative hypothesis instead. Let's talk about this a little. So let's take the example that we just calculated in one of the previous videos. You remember that we have an assumption about sugar content in all apples of the population. It's 10 or above. We got in our sample 9.5. This is confidence interval. This is the p-value. So in this case, you can see that it is possible to have 10 or above in the population, right? Both confidence intervals and the p-value supports this. However, the p-value is relatively small, right? So it means that you either get this p-value just by chance. I mean, 3.3% probably it's okay chance, right? So sometimes even these unlikely events happens, that's possible. Or maybe null hypothesis is wrong. So this p-value is so small, 0.033, because null hypothesis is wrong. And therefore you should take the alternative hypothesis instead. Well, if you don't need to make a decision, if your experiment is just to show some evidence, then you don't care. You just show the p-value, you show the confidence interval, and based on this, you can make some reflections. But if you need to make a decision, if you need to proceed either as if null hypothesis is true or if alternative hypothesis is true, then you need to find out which hypothesis to support. Okay. So this is just some examples when you need to make a decision. For example, you assess contamination of lake, and then the result of this assessment should either initiate cleaning process or not. If you initiate cleaning process but lake is not contaminated, you will waste a lot of money and resources. But if you don't do that, then you have a risk that, for example, this lake is getting more contaminated, and therefore it will lead to some, for example, problems with the flora and fauna in this lake, or maybe even something that can harm people that lives around this lake, right? Or maybe who swim in this lake. For example, you test a medicine, and you need to make a decision. Either you need medicine works and you need to continue with the next test stage, or medicine doesn't work and you should stop. Again, it's a very difficult decision, because if you continue with the next test stage, usually testing medicine is very expensive. Every next step is more expensive than the previous one. And therefore, if medicine doesn't work and you continue as if it works, you will waste a lot of money. But on the other hand, if medicine works and you say, oh, it seems like it doesn't work, then you potentially will lose an efficient medicine, right? So, and many, many other things. So sometimes you really need to make a decision based on the p-value. In this case, you have two possibilities, right? So you either assume null hypothesis just by saying that this is not strong enough, so this 3.3% is still quite a big number, or you reject null hypothesis and accept the alternative hypothesis, assuming that this value is small enough, so it's a strong evidence against H0. How to do it? Well, typically we do the following. We define a threshold for the p-value. This threshold is called a significance level, alpha. Okay, and then if p-value that you got during this test or after this test is smaller than threshold, then you reject null hypothesis and accept the alternative one. If p-value does not exceed this threshold, then you accept null hypothesis. The problem is you never know if null hypothesis is true or not. And therefore, if you reject null hypothesis and it's true, then you will make a wrong decision. And this significance level that you select, it's exactly the chance to make this wrong decision. So if you reject null hypothesis, but it was true, then you will make a wrong decision, and alpha gives you a chance that you will do that, right? For example, if you select alpha 0.05, very common value that almost all scientists use, which is not very well supported, we will discuss it, then it means that you will be wrong in 5% of all cases where null hypothesis is true. So if you say, from this time point, I'm going to use alpha 0.05, it means in the future, 5% of your test, in 5% of your test where null hypothesis was true, you will make a wrong decision. Okay, that's a pretty big number, isn't it? If you reduce alpha to 0.01, then the chance to make a wrong decision is reduced at 5 times. So you will have 5 times less wrong decisions when null hypothesis is true, right? So strictly speaking, it's highly recommended to use alpha as small as possible. It has a price, we will discuss it. And you can also vary. Sometimes 5% is okay, sometimes even 1% is too large. So again, we will discuss all possibilities and we will discuss different situations in this learning sequence. But now just know that the significance level, it's the way to make a decision. Yeah? The most important thing is that you define alpha before you start doing the experiments, before you take in a sample, before you make in a test, and never change it. That's the most important thing. Otherwise, it will be very tempting to make it smaller or to make it larger later. So make an educational guess about your alpha and never change it after that.